Hi everyone, this is Dr. Saida Falafini from Cal Poly Pomona. In previous video, we talked about how we can use queuing theory for identifying the capacity of the nurses or the number of nurses needed in each shift in each day of the week. In this video, we are going to talk more about how we can identify the schedule of the nurses so that we can accomplish the number of nurses that we need for each shift. Now that we know how many nurses we need at each day um, and in shift one, I also need to provide a schedule for the nurses, so that to say how these nurses have to start working in different days, such that I have these number of nurses at each one of these days, so that I can meet the requirements of the customers. And as we said, the only condition that we have to meet is that when the nurse starts working at a specific day, they have to continue working for 5 days, and then they can take 2 days off. Okay. So this is something that we can solve, or we can find out by using linear programming, another technique under the umbrella of operations research. So obviously, my ultimate goal is to make sure the number of nurses that I'm going to use to meet this demand is as low as possible. So I want to minimize total number of nurses that are going to start working in this week. The ones that start working on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So why do I want to minimize it? Because I'm paying salary to this staff, and that's a resource for me. So I don't want to use more than what I need. So I want to be able to use the minimum number of resources that can meet this condition, that's for sure. But I want to make sure that the number of resources minimum. And then, okay, what is the other condition that we want to have? So what I want to make sure is that on Monday, I have 5 nurses. So can you tell me, obviously the number of nurses that start on Monday, X1, they are going to be counted toward these 5 nurses that we need on Monday. And then can you tell me which other nurses are going to work on Monday as well? A nurse that starts on Tuesday, do these nurses will end up working on Monday ever? They start on Tuesday and they need to work 5 days and then 2 days off. So if they start on Tuesday, they need to work up to Friday, and then they take 2 days off. So they are off on Sunday and they are off on Monday. So a nurse that starts working on Tuesday will not work on Monday. How about a nurse that starts working on Wednesday? Would they end up working on Monday as well?
No.
No, because if you start on Wednesday, you continue working for 5 days up to Sunday, and then you take Monday and Tuesday off. How about a nurse that starts working on Thursday? Do they end up working on Monday as well?
Yes.
Yeah. So they work on Thursday, Friday, Saturday, Sunday. That's 4 days. They continue working on Monday as well, and then they take Tuesday and Wednesday off. So for those nurses that start working on Thursday, and that's X4, they end up working on Monday as well. And with the same logic, the nurses that start working on Friday, X5, they end up working on Monday too. The nurses that start working on Saturday and the nurses that start working on Sunday, they all end up working on Monday. And so, okay, so this then tells me or gives me total number of nurses that will end up working on Monday. So what do I want for this? What should we put next? So, and I know I need 5 nurses on Monday. And this sum gives me the total nurses that will end up working on Monday. And from queuing theory, I know I would need 5 servers or 5 nurses on Monday. So what should I put in between these two? Less than or greater than or equal? Which one?
Ideally
Greater
equal
than.
to 5, greater than or equal to.
Okay, someone else was going to say something. Vicky, what about you?
No, same thing.
Okay.
Greater or like equal.
Okay, oh, that's fine. Okay, yeah, so in an ideal scenario, I want this to be equal. But equality is a very, very limiting constraint for a mathematical programming or linear programming or any mathematical programming. So the best scenario, which gives more flexibility to the model, is to say that this is going to be greater than or equal to 5. Greater than, because if it just happens that we couldn't make it to 5, it's okay to be more than 5, because we do want to meet the customer requirements. We don't want to have less than 5, because in that scenario customers need to wait forever. But we want 5, but then if it's okay if it also ends up to be a little greater than 5. But what is going to force the model to make sure this is close to 5? Which part of the model will do that part to make sure that this sum is actually as close as possible to 5?
Minimizing the total number of hours or like total number of payments going out.
Exactly. The minimization here, which will force the value of x1, x2, blah, blah, to be as small as possible, and then at the same time meet this condition. And I do the same. So this is for Monday. I write the same condition for Tuesday. So for Tuesday, number of nurses that start on Tuesday is x2, and then I also need x5 plus x6 plus x7 plus x1, the ones that start working on Monday, to be greater than or equal to 6. And I'm going to continue writing that condition for Wednesday, Thursday, Friday, Saturday, and Sunday. And that will give me basically the linear programming. So that's a mathematical model, which basically says find the value of x1, x2, x3, x4, x5, x6, x7. All of them I know are greater than or equal to 0. These are the number of staff that should start working on Monday or Tuesday, Wednesday, blah, blah. So they can get negative value. All of them are going to be greater than or equal to 0 for sure. What I want this mathematical model to do for me is to find value of x1 to x7 such that the total number of staff that I'm going to have on Monday is greater than or equal to 5. The total number of staff that I'm going to have on Tuesday is greater than or equal to 6. Total number of staffs on Wednesday, Thursday, and Friday are greater than or equal to what is needed. But at the same time, I also want to make sure I don't hire too many staff. I just want to also make sure the total number of staff that are going to start at some day of the week, the sum of them is as minimum as possible. It's the minimum possible level. So that's in that scenario, I use the minimum amount of resources or the minimum number of staff or the minimum number of doctors to meet the requirements of the patients. Okay, so that's basically the linear programming that we need to write, and then we can either solve it using using simplex method or using the different softwares, Lingo, Lindo, and all of those, to find the answer to this linear program. And that, when we find the answer to this, at the end, we have a schedule of the staff to tell exactly to our staff that, okay, maybe 4 of you have to start on Monday, and 1 of you have to start on Tuesday, and 2 of you have to start on Wednesday, and so forth. So that would be the schedule that I want to give to my staff, and just say, okay, this number of you have to start in these days, and then you have to continue working for 5 days, and then you take 2 days off. And if my day has different shifts, then I do the same thing for the second shift. I do the same thing for the third shift. Okay, and this is an example of the scenario in which I use queuing theory and linear optimization to develop the schedule for the staff. The queuing theory step, the first step where I use queuing theory, helped me to find out how many staff I need each day. That's what I found through queuing theory. How many staff I need each day, how many servers I need each day. That's what I got through queuing theory. And those are actually the numbers on the right side of the constraint. So these are the number I got from queuing theory. And then using linear optimization, I found out how should I schedule my staff so that I make sure I have this number of staffs in these days of the week, in those shifts and so forth. Okay. So that's an example of the scenario. Again, everything is under the umbrella of operations research, but for capacity management, operations research is probably the most, the strongest tool that you guys have for planning number of beds, staff, equipment, and so forth. Okay.